Hello, welcome everybody. Nice to see there's a few people out there who could join me for the live stream, so welcome and thanks for that. If you're watching the video later in the week, hopefully you're having a good week. We're in week 12, so we're not that far from the third project being due, and I have been doing examples, building up an example for the last 2 weeks. Today I'm going to start just do a different kind of setup as an example for how you might consider going about project 3. We're not looking for great works of art, but you certainly have the space in project 3 to be creative if you would like to do so. But if you notice the requirements on project 3, which we'll have a peek at toward the end of the live stream today, if you look at the requirements, you'll notice that the requirements are technical requirements. So this is a computer science class. We're not looking for great works of art, but if you have fun with the third project, then that's great. Hopefully, if you find something of interest to do in it, then that's wonderful. And enjoy doing that, and we'll enjoy sharing your work with me, and then hopefully getting to do a demo of it. Okay, so why am I saying that today? Because we've looked at how to use slices as a way in project 3 to collect items when you move around the different locations. So we'll look at slice expressions today, I think, as a way of sort of creating a game maybe where you pick up specific keys to unlock things or something like that. We'll see. Let me start by going through demos from last week's work just to show off some interesting things that people did with the labs, which is pretty awesome, by the way, that some of you are putting the work in to actually make the lab something interesting for the rest of us to enjoy. So that's a super cool thing that you did that. So let me just, whatever. I'll grab some code, I'll plug it in, and we'll see what a few different people did with the labs from last week. I picked these. I don't remember because it was kind of a while ago in my mind that I did this. So anyway, I'll just show you that it doesn't really matter. I guess I can punch in some stuff. Anyway, this one's cool. So this person's kind of figured out how to put interesting interesting sort of non-regular characters in the screen just to make it more fun to look at. This is a great technique for making a text-based game look cooler, is to do this kind of thing. So my bet is that the person who did this work went and used a Google search to figure out how do you do sort of these special kinds of characters in their output. By the way, the Go language will also handle emojis, so you can actually put emojis in your source code and print them, and they will print to the screen. So yeah, you have a lot of options there. So anyway, nice work on that one. And then I think probably I picked ones. I picked one. So this one, just they took the extra time just to space things out nicely on the screen. You'll notice like the sum of temperatures and the average of temperatures are lined up, which didn't take this person, no doubt, a long time to do it, but it took time to kind of just run their program, study the output, and then do that extra work to do some alignment of the outputs, and it looks nice for the effort. So I appreciate when someone sort of puts the extra work in to get something nice looking, even on a lab. So that is good stuff. This one also just kind of has some flair to it on the screen, which is, oops, whatever. Oh, I said I was going to put in 10. Oh yeah, so this is the one where the person actually figured out how to let the user say, I want to put in this many numbers, and then you say how many numbers you're putting in, and then it loops that many times, and then does the calculations for you, and also the little kind of flair in the outputs as well. So that's a good piece of work. These are just labs too, so I respect that a lot. that a person puts the extra work in on a lab, knowing that we're going to do one of these every week. But the practice is good. The practice pays off because you are developing skills that you can then use to do bigger and better things later. So anyway, this is another one where they took the time just to put the little dividers in there. Shows you what section you're in, running float slice, running string slice. So anyway, those kinds of touches are really nice for me to experience when I'm grading 56 of these things or so, somewhere in there. And it's also nice for me. It's also nice for the person who did it because they are adding to their toolkit, building their confidence with the extra practice and the extra work. So anyway, totally pays off, and I appreciate and respect the work that people do when they do that, which is why I do the demos, just to show it off. So that is really cool stuff. Okay, so let me, what's going on up here? This looks different. They changed the interface on this website. Yeah. No big deal. It just, I could tell immediately it looked different. Okay, so we are doing slice expressions this week. So we did arrays, we did slices, and slices are really just dynamically sized arrays. And now we're doing slice expressions. And it turns out that you can use slice expressions on arrays or slices. So I have my drawing pad out tonight to show you a little bit how these work. But the first thing I'm going to do is just show you what they look like in code, and then we'll go explore kind of what the meaning of the things are. So you can use a slice expression on, let's say, I like to use fruit. So let's do it on a string array so that you get accustomed to the idea that these slice expressions can be used on slices or arrays. So slice expressions, I don't know, it's unfortunate terminology that the Go language developers chose, in my opinion, because it can confuse people. So what's a slice versus a slice expression? So a slice is a fancy dynamic array. A slice expression is a way of creating a window on an array or a slice. So what helps me to conceive of it anyway is that you can, I can take a slice of a slice. If you think about a pizza as an example, if I take a slice off of a pizza and I cut the slice in half, that's a slice of a slice. And that's kind of what slice expressions allow us to do, is take pieces and parts of a slice or pieces and parts of an array, kind of slice them up. So slice expressions, it's a little bit different, and it has a funky looking syntax when you first see it, but they're super, super cool. And there's actually sort of a cool trick we can do with them to create a set of keys for a game that we could then use to make a puzzle out of, which I'll show you. Apple, orange, I don't know, cherry. Got to do 5 of them. Kiwi, banana. So anyway, here's what they look like, and then I'm going to run the program, and then we'll explore them, and then I will go draw pictures in the hopes that the pictures maybe will help you better understand what's going on. So I'm going to slice this thing, and it's going to look funny because I'm going to do all the different options here. So ooh, a little arrow. All right, so here comes a slice expression. It's that colon in there. So the colon in the square brackets is the clue that you see in code that tells you that a slice expression is happening, which means that I am taking a smaller part, or sometimes all of the part. If you've done any kind of set theory in a math class, that you have sets and subsets. So slice expressions allow you to take subsets of arrays and slices, if that helps. And one of the subsets of any set is the entire set. And then you can have subsets that are smaller parts as well. Anyway, so this is a slice expression, and it is a slice expression that includes the whole array. Why would we do that? Well, we'll see a trick later that will show us why this is an interesting feature in the Go language that we can actually take advantage of to do things. But anyway, this is a slice of an array that includes all parts of the array. So there it is: apple, orange, cherry, kiwi, banana. So a slice that includes all of it. Slice that starts somewhere and goes to the end. That's getting to be pretty long, but I think actually let's just say, let's shorten these up. We'll say slice with all of it, slice with start point only. This is what that person did who had the things lined up, by the way. It's not hard. It just takes a moment to stop and do it. So here we go. Let's do another slice expression. We know when we see the colon rather in the square brackets, we've got a slice expression. If we put a number in front of the colon, we can start somewhere. So what this is saying is start at position 2 and run off to the end. So giving it a start point. Position 2 in array, so apple is position 0, orange is position 1, cherry is position 2. So what I'm saying here is give me a slice of this array that's only from position 2, and then since there's nothing after the colon, it's starting at position 2 and running through to the end. So I should see cherry, kiwi, and banana for this slice. Cherry, kiwi, banana. All right, here's the funky one. Besides the slice of all of it, so slice with endpoint only. And then I'm going to put a star here because it's a little bit different. So fruits, we're going to do a slice expression. The square brackets with the colon tells us that a slice is about to happen. So you'll notice that when I had a start point, and you'll see this in the agenda, it says includes the starting point. So start at 2 and including 2 to the end. So what we're going to do now is we're going to put an end point of 2. And the end point is not included. It is one beyond where you stop. So what I'm saying here is stop before you get to position 2. In other words, pick up position 0, pick up position 1, and stop. Stop before position 2. So that's unfortunate because the starting point is included and the end point is one past where it stops. So if I stop when I get to position 2, that means that what I get in the end is position 0, apple, position 1, orange, stop. Okay, so there's apple and orange as expected. And now let's do both. Let me line them up again. All right, so now let's do a start point and an end point. So let's start at position 1. The starting point, remember, is included. So if we start at position 1, that's orange, which means that orange is included. And let's go all the way to position 4. So the end point means stop one short of that. So I'm going to get position 1, position 2, position 3, stop. So position 1 is orange, position 2 is cherry, position 3 is kiwi, stop. Okay, so there's orange, cherry, and kiwi as we would expect. So that's slice expressions. That's all the variations on the theme that you can have. Now it turns out that you can I guess I'll come back to that in just a second. So I don't know if it's going to help that I draw a picture or not. Maybe I won't bother. I'll think about it. But we'll keep going for now. Well, yeah, let me just try it real quick. So just for a couple minutes, let me switch over. You see my little props here. So let me make an array of numbers. The reason why I don't use a graphics pad is because it's too uncomfortable for me to use a graphics pad. I just am awkward with it. Okay, so there's an array or a slice. It doesn't really matter, but I just thought it might be helpful to think of a slice expression as a way of sort of making windows on a slice or an array. So if I have this array, I'll just call it A. So if I were to say A to 3, well, what I'm saying is start at the beginning and then go 0, 1, 2, stop before you get to 3. So that's the window that I would get on the slice. It doesn't change the slice, it just gives me a window on it. So that's all slice expressions do, is give me a window on this thing. Now the nice thing about windows, as you'll see in a little bit, is that you can use them. Oh, thank you, D Rose the artist. Thank you. I'm glad that's helpful. I mean, it helped me. So there's my little window, and it helps me also to think of slice expressions as creating a little window. Now, the important thing about the window also is that you'll notice that the slice doesn't change. I'm just creating a window on different parts of it. But that can be useful. So let's do one the other direction. So we'll do 3 to the end. So what does that mean? So we go 0, 1, 2, 3, and then to the end means basically all of it. So there's the window that this slice expression creates. And then I can do one more, and then that'll be my little drawing. So anyway, these are little windows when you have the colon. So start at position 1, so there's 0, here's 1, and then I go, that's position 1, 2, 3, stop, 1 short of 4. So that's the window that slice expression gives me on that array. Anyway, so sorry about the cruddy hand-drawn stuff, although I do have this little index card as a prop. So when I was a computer science student, I was a big user of props like this. So I sort of have a whole toolkit of different ways that I create visualizations for myself. I like index cards and strings. When you encounter pointers, that's the way that I first kind of got a handle mentally on what a pointer is. We don't have that to worry about right now. But this is the kind of thing that I did to understand kind of what slicing expressions do. Okay, so switching back over, so you don't have to look at my terrible handwriting anymore. So that's what we're doing in code, and you can see these little windows that I've created. And it's important to note that, well, and you can kind of see it in the code, but just keep it in your head that a window on it is still underneath there. The whole thing is still there, and these slice expressions are just giving us this little window that we can move around. So why would we do such a thing? Well, let's look at an example of that. I'm going to go above the fruit stuff, so I'm going to comment this out. Why would we want a window of things? Well, let's say, for example, I'm going to go ahead and make some random numbers into a slice, let's say. No, let's do it in an array. Does it matter? It doesn't matter. All right, so we're going to need math rand and time, and we're going to populate an array with some random numbers. So we're going to do rand.seed time.now Unix nano. I think I've memorized that for this semester. First semester ever, by the way, that I managed to memorize that. I usually have to look it up because I forget. Now I can do random numbers. So let's give ourselves an array or a slice. Does it matter? I'll do an array. Call them randos. We'll make, let's make 1,000 of them. 1,000 integers. And then I'm going to loop. I'm going to use a counting loop this time. Remember, on the length of slices and arrays, compute it. Don't hard code the length of slices or arrays. You will come to regret that. It's a very bad habit to be in. Since Go lets us compute the length of every slice and array, and a slice created as an expression, there's no need to ever hard code that, and that reduces errors. So one of the errors that, just to make this argument real quick, one of the reasons why I say to compute the length is, what if that code for this loop was way far away? And at some point I decide to make this be 100 instead of 1,000. Well, I better darn well remember to go down and fix this 1,000 to be 100 or my program's going to crash. Or I can simply compute the length and then I don't have to worry about it anymore. So if I change the length somewhere way up here, I don't ever have to worry about, no, where again did I hard code the length? I don't. It's just automatic. So that's why we like that. Even though in this case they're right next to each other, doesn't matter. It's still the habit that you want to be in so that this doesn't bite you somewhere down the road. Okay, so let's populate it with some numbers. So we will do, oh hell, let's do 1,000,000 of them. So we'll go randos. We will hit each position with a rand.int n, and let's just say a random number between 0 and 99, but let's bump it up by 1 and make it 1 to 100. Okay, so it's 1,000,000 of them, which means that there's no way I'm printing these things out. Now, why would I do this? Well, let's start just by saying the first 10 values are, so I have 1,000,000 random numbers, but let's just say I want to see what the first 10 of them are. Well, no problem. Take randos, go up to, but not including position 10. But if I say 10, then I get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is actually 10 of them. So that's the first 10. The last 10 is harder to do, or is it? The last 10, in theory, line those up. The last 10 values I can get by doing this. I can actually use the length of the thing, back off by 10, and start there. So I'm going to go all the way to the end, back off by 10, and then grab everything from that back off by 10 back toward the end, which is another place that knowing how to compute the length of an array is handy in that it lets me make slices. Let's see if I got 10. Okay, so hopefully it runs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there they are. First 10, last 10. But let's add now a capability that we are going to use in the lab. So let me open up a tab and do golang sort. Okay, so there's a sort package in the Go language. This isn't the, that's not what I wanted. I wanted the official documentation for that. Where is the official Golang? Well, it looks funny. That's fine. Let's see if this gives us enough. Yeah, here we go. So we can sort an integer this says slice. We'll try it on our array and see if it will sort it. So I need to import sort, and then I'm going to sort a grouping of integers. Let's see if we can get that working in code. So import sort. And let's then see if we can sort a set of integers that is my randos. Let's just see if that works without any help first. Nope. It wants a slice. I don't know if you can see that, but I'm trying to use an 1,000,000 integer array on a function that wants a slice. I have a trick for that because I can actually just make a slice window on all of my random numbers, and now the function, given that window on all of them, will be satisfied. So now they're sorted, and now I can say, we're going to go back over this trick when I talk about how to do the project and do a little key set. So it turned out that if I try to just pass an array to this sort.ints, I get an error. And what the error tells me is that I cannot use an array. Well, that's a bummer because I want to sort this array, but it says I can use a slice. So one of the cool things that you can do with a slice expression is that you can take an array and plug it in where a slice is required. So this slice expression actually more or less creates a slice window on an array, and now the function is happy to sort it for me, and I too am happy for it to be sorted. So what we can do after sort, though, is we can say the smallest, let's say the smallest, I don't know, 5 values are. So now it's sorted. I can say go 0, 1, 2, 3, 4, stop before I get to 5, but that's 5 of them. And then I can say the largest. Let's go, I'll do 5. 5 values, or line those up. Same trick. So I'm going to go all the way to the end. And then I'm going to back off 5 to get the last 5. So once they're sorted, I can actually use slice expressions to tell me what are the biggest and the smallest ones. So they're all ones and hundreds. That's not a surprise because the range of random numbers is quite small. Let's make the range of random numbers be much bigger and see if we get anything more interesting. A little bit. A little bit. We can also do this, by the way. The value in roughly the middle. I'm going to drop this down to the next line because it's going to run over. So this is a way when you have a run-on code line, just drop it down to the next line below and continue from there. Okay, so I'm going to slice this thing up. How do I get to the middle as a starting point? Well, I can take the length of the thing and divide that by 2, which gives me roughly, right, the middle spot. And then I can do the same thing here. I can slice it, not slice. What? 2. Yeah, that's the first half. And then where do I stop? I will go the length divided by 2 and then shift over 1 from there, which will give me the 1 element right in the middle. So what I'm telling the slice expression here is go to whatever index computes is the middle, which is 1,000,000 divided by 2, which is 500,000. And then it says stop 1 forward from there, but I know that if I stop 1 forward, it actually stops 1 short of that. So this kind of slice expression, which I didn't write correctly, picks up one thing. So if I go to a location and then tell it to start there and tell it to stop one past that location, which is actually that same location, then my slicing gets me one thing. So let's see what the value more or less in the middle is. Somewhere I made a mistake. Oh yeah, I took the parenthesis off. That's what it was there for. So this value 499, 420 is roughly in the middle of all of the random numbers, which makes sense, right? It should be roughly 500,000. So randomly, that's what it was. Yeah, so there's a much more elaborate slicing operation. I could also have done this, by the way. And then I could have rewritten this, comment this version of it out. Could have rewritten this as the middle point. And then if I stop at the one over from the middle point, that really means stop one short of the middle point, which is that same, that's a way to get one thing off the slice. Same result, it's just I could have used a variable instead of computing it in place, which is a little bit easier to read. Start at the middle point, end at the middle point. Okay, so we saw actually here a couple of different things that I hope demonstrate why slices can be useful. We'll go over more examples of this, but one way a slice can be useful is that it allows us to plug in an array where a slice is needed, which will make more sense when I give you a function example here in a moment. So that's one thing that a slice can do, is it gives us the ability to plug in an array where a slice is required. Another thing that allows us to do, though, is, for example, if we have a set of data and they are sorted in any way, we can look for the middle point, we can look for the smallest ones, the biggest ones, by slicing off or creating windows just onto those smallest and biggest values. Kind of a cool thing, at least in my opinion. I think that's kind of cool. Where am I at in terms of my agenda? Yeah, okay. So we're doing great on time today. I don't even know if we're going to go the whole time. So I'm going to give you one example to try to explain this idea of plugging in an array where a slice is required. So what does all that mean? So let me comment this stuff out. Yeah, I don't think I need the random numbers for the moment. Do I? No. I don't, which means I don't need this, don't need this, don't need this anymore. Okay, so let's say we have a function and we say double the values of some array. So let's just start with an array. So we will say values, which will be an array of 5 integers, let's say. And what we want to do here is we want to say for I ignore, I'm going to use a range loop just so we get the practice. Range over values, and we're going to say values at I equals values at I times 2. So we have this function. What we'd like to do is send in an array. It's going to be limited to arrays of size 5. That's already kind of a bummer, but we'll let that hang for the moment. And then we'll double all the values. So let's try it out and see what happens. So here's our array. We will do so it's going to have to be a size 5 to match the function. 50, and let's print them out before the values. Now let's double them. And now let's print in after. Get those lined up a little bit. and see what happens. Okay, so this is why this slice expression stuff can be so cool with arrays. So this is a new concept, multiple new concepts, but do you notice that you will notice that the values didn't actually double? So here's the catch. When you pass an array to a function, what actually happens in Go is that Go will make a copy of the array. So all of the work being done here is being done on a copy of this darned array. All right, so that's kind of a bummer. What happens if we change this to a slice and we change this to a slice? What happens? Does the fact that something is a slice make a difference to Go? It does. So one of the reasons I was showing you the little window is because a slice is actually just passing to the function kind of a window onto an array or slice, but the function can actually use the window to edit the underlying array or slice. Hopefully you tracked that. If I pass an array, Go will make a copy. That's just how it works. There's no getting around it, which means that all of this work is being done on a copy, and that doesn't help me just a whole lot. So we just discovered that if we pass the function instead a slice, the function is able to use the slice as a window that it can work through to the original piece of data back over here. And I converted this to a slice so that they would match and it would run. All right, so what if I put the array back by coding the size and then try to send the array through? What happens? Okay, I get an error because the function wants a slice and I'm trying to send an array. So we saw this with the sorting function. So I have an array, but I want to use a function that requires a slice. What do? I don't know if I have anybody in chat who's willing to have a crack at this. But I have a technique I can use, and you can either chat it as code or chat it as your idea about a description of the technique. So is there a way for me to kind of provide the function with a window back onto an array here? And if you don't know the answer, it's okay, but I'll sit on it for a moment and see if anyone knows what I can do to get my array to that function, even though they technically don't match right now. It's a hard one. Okay, so we've seen this kind of error before where it says, hey, you have a size 5 array and the function wants a slice, which is not a size 5 array. The trick is to use a slice expression to create this slice window so that the function will, in fact, operate back through that window onto the original array, which is super, super cool. You may not realize it yet, but it's a cool thing that I can sort of puncture this barrier with a slice expression. Here's something else we could do, by the way. Let's see what happens if I slice it starting at position 1 and ending 1 short of here. What does that look like? So I don't know if you can see it, but only position 2, 3, and 4 got operated on by that. So I actually sent the function a window onto a subset of my larger array, which I just think is really, really cool that I could do that. I don't even have to send the entire array if I don't want to. I could just slice it off, make a window onto a smaller part of the array that the function then operates on. The function doesn't know any better. It just says, whatever size of window you sent me, I'll operate on that. I just think that's a very, very cool thing. But let's leave it as sending the whole thing in. So slice expressions allow us to sort of penetrate this array to slice barrier with functions. And we're going to use that in my little project 2 idea. Project 3, sorry, idea here in just a little bit. That's the hardest one. Practicing on how to create slices is a lot less hard than this function one. But I'm going to give you more another look at it here when I fire up a new version of Project 3 for myself in just a little bit. Okay, so slice expressions allow us to create windows that are subsets of arrays and slices. And then one of the cool applications that's harder to understand, but hopefully you will eventually understand, is that a slice expression allows us to actually plug in an array in places where slices are wanted, which is just a super cool thing to do. Okay, so there's that. Let me fire up this is new. They used to have a little hamburger menu up here, and now it's closed sidebar or menu. So they changed the interface on Replit. Let me create a Replit, and let's go do some lab review, and then I'll put a small break in before I do some Project 3 work, so that if you don't want to see it, you can leave, or you can get up and stretch your legs if you do want to see it. So let's do so 20, lab 12. So let me go get the lab code here. I never did walk through the module, did I? I guess I can do that while I'm at it. Project 3, let me open that so I can come back to it. And then let's get slice expressions, week 12. You're going to get more practice on slices with functions next week. So if you don't quite understand that, not to worry just yet. We aren't really hammering away at that until next week. Okay, so I'll just walk through the module and then I'll come back and grab the lab stuff and we'll look at it. Slice expressions. So the slice operator, it's the colon inside of square brackets. And then we're going to complete the implementation of a series of functions that ask us to cut slices onto arrays and cut slice expressions, as it were. Okay, homework as always, based on the readings. Let me get the lab open. So you'll notice that this lab this week is unit tested. So please read the instructions and make sure that you do that. We've had a couple of weeks with no unit tests. This week we are back using unit tests. So make sure you have that so that when I go do the unit test, notice that 90 points is passing the unit test. So if the unit test is there, you can't pass any of it. Just please don't forget that's coming back to the unit test. So let me grab, what am I here for? Oh yeah, I'm going to come back and grab that code in just a moment. I'll go ahead and open up the test code too and bring it along. Okay, so lab. Discussion. So we've done test-driven development before. So now hopefully we can be, now that you've done some test-driven development, that's what the unit tests are all about. You can do a little bit of research for this week's discussion on Piazza with a little bit more background in terms of what does it feel like to have to use unit tests around your code. And then there's some extra sort of prompts here to help your searching. And the idea, of course, is that you as an individual don't need to answer all of these or all parts of any one of these. Just pick one of these that looks interesting. Go do research on it with now your experience with some unit testing and see what you find. One interesting thing as an example is do big companies do unit testing? Does Google do unit testing? Does Facebook do unit testing? Do big companies like those do unit testing? Presumably they do. Hopefully they do. And then the reminders, which includes Project 3 due on November 20th, which is important to note because if you have other classes, probably you have other teachers who are trying to help you clear out heavy work before Thanksgiving week because many people are distracted by work, family, friends, activities, the desire to take time off, whatever it is. Thanksgiving week can be distracting, so we'll get our project done before then. I will do a normal live stream and content that week, which hopefully you can clear out quickly if you want to do Thanksgiving related stuff. But anyway, that's why the project is due before, so that the big lifting is done before that weird distracting week happens. Okay, so that's the walkthrough of the module. Let me grab the lab code. I'll get the unit test so that you have seen me do that, so that maybe you will not forget to do it. main_test.go. Plug in the unit test. Don't need that anymore. And we'll get the starter code, and we have a good amount of time this week to look together at what is required. So the setup right now should allow me to go ahead and run the unit test and then fail everything. Yeah, so I fail just absolutely everything, but that's fine. It does run the test, and that's a start. Okay, so here we go. We just did this one. So the sample that I did, this one wants you to slice off the lowest 3. So I did a sort, and then I grabbed the lowest 5. The highest 3, so do a sort, grab the high 3. I did that in the examples as well, so I'm not going to waste your time with that. Let's try this one. Drop highest and lowest, sorts a slice of floats, and returns a slice containing all of them except for the first one and the last one. So let's do this one together and work out the slice expression to cut off both ends. First thing to do, it tells me actually sort float. So I'm going to sort float 64s of the values here that I'm being given. So easy enough. Now we have to, instead of returning nothing, we're going to return a slice of these values. This would be all of them. So I need to cut off the first one. So the first one is at position 0. So if I start at position 1, I will have cut off position 0, and that's great. How do we cut off the one at the end? Well, we use the length of the values to go to the end, and then we back off 1, which cuts off 1. That's it. We didn't do this exact example, but when you need to get to the end and come back by some, you use the length of the thing, and then you back off by 1. I don't know what the length is, so I have no choice here but to compute the length anyway. Let's see if we pass any because of that. Go test star.go. I'm going to have to do a -v to see if I get any passes going. I see a pass. Here's a pass right here. That's an accident. I'm just giving. Here it is. Drop highest and lowest. I passed, except for I'm failing drop highest and lowest of an empty slice. So maybe I should read the instructions better. Drop highest and lowest, sorts a slice of float 64, done, and returns a slice containing all of the float 64 except the first and the last. If the slice contains 2 or fewer items, return it without removing any elements. Aha, 2 or fewer. So if the length of the slice is less than or equal to 2 or fewer, 2, then I'm going to return the whole darn thing. Otherwise, I'm going to return cutting them off. Makes sense. If there's 2 or fewer, I can't really slice off anything because I need to keep the 2 or fewer. So, but I noticed I was failing one of the highest and lowest tests, which was the empty one. So anyway, I came back and I read more carefully the instructions, and I realized that what it told me is sort them and then make sure that if the length is 2 or fewer, less than or equal to 2, just return the whole thing after sorting it. Otherwise, I can slice it up. All right, so let's see if that improves my outcome on that test specifically. Go test star.go. Verbose mode will show me the passes. It doesn't crash anymore, by the way, so that's good news. Okay, so here's a run and pass on drop highest and lowest. Here's a running pass on empty. Awesome. Here's a run and pass on only 1 element. Here's a run and pass on only 2 elements. And here's a run and pass on only 3 elements. I'm passing all of the drop highest and lowests now. Life is good. First half. First half returns the first half of a slice of strings. The first half is computed as the strings from the beginning up to but not including. The index computed as the length of the slice divided by 2. If the list is empty, return it without doing any work. I'm being more careful now because I failed and crashed earlier without reading the whole instructions. If the list is empty, return the list without doing any work. Okay, so that means better check that first. Why am I putting these parentheses here? Go doesn't require them. If the list is empty, meaning it has a length of 0, return it just as I got it. Fair enough. Otherwise, I got stuff to do, so I will return a slice of it. The first half. So that means start at the beginning, which means I'm not going to have any value there, up to the halfway point, which is, and up to but not including, well, that's built into the way this works. So up to but not including the middle point, which is computed as the length of the thing halved. We've done this a little bit as well. So start all the way at the beginning without any starting point, means just right at the beginning, but stop 1 short of halfway through, which is what it tells me to do, up to but not including, 1 short of the index, the location, in other words, computed as the length divided by 2. All right, so does that help me pass any more stuff? Let's look for, what did I do? First half. Oh gosh, I don't want that. Put it at the bottom. No, how do you get it at the bottom? There we go. All right, so it was the first half stuff. So let's find the first half tests in here. All right, so here's a run and pass on first half. Here's a run and pass on first half empty. Here's a run and pass on first half 1. A run and pass on first half 2. That was it. So there's first half, which should be hints on second half. Except for second half is start somewhere, running off to the end. String in the center. We did this. The thing to be careful of, though, is these instructions that say if the list is empty, don't do anything, just return it as it was. Notice that same instruction happens on second half. That same instruction happened on first half, which is what I did. So use first half as an example. Second half is similar to first half. The center point I did in the sample REPL, which I need to give you a link to in the lecture notes. Doing good on time. This program has a main, by the way, so we can run it instead of just testing it and kind of see what's going on here. So you can run little experiments on the side apart from the unit test if you want to in this main. That's all of them. I've shown you examples of doing all of them. So I'm about to take a short break and put a break in the video that says be right back before I do some project 3 work, so that if you don't care to watch that right now, you don't have to. If you are coming back later and want to hone in on my ideas for a different way of doing project 3 tonight, those will be available to you. So yeah, that's what's going to happen. I'm going to put a be right back. It is 4:56. I will be right back at 5, and I will finish inside of the normal scheduled hour and a half, which is unusual for me these days, but that's good news. So anyway, coming up soon, in fact, in just a moment, is a be right back. I will be right back exactly at 5 p.m. as my computer says it, which it's 4:56, and I will do look at how to use a slice expression to create a game where the point is to find and use keys. All right, so be right back in just a moment. Okay, so I'm gonna do a different a variation on the Project 3 um, game. So I've been putting links to this version 1 of my Project 3 idea in the lecture page. So that's been there for the last 2 weeks. I'll also put version 1 out there this week just so it's easy for you to find. So my version 1 was basically the idea would be that the player can collect items and you can check to see if they have them, and then you can use their items. You can use the fact that they have them. What I'll do next week, sort of as the last week before it's due, is I'll bring these two ideas together. But for today, let's just look at sort of a lock and key kind of puzzle idea. So I'm going to use the theme of keys in my version 2. But it could be, you could use this for tracking items or any number of other things. So hopefully this has given you some food for thought. Let me bring my clear screen and pause with me because those are handy to have. So let me make a new one. Go CSCI 20 P3 V2. And then I'm going to go a little bit faster for some parts so that you're not kind of just bored to death with repeat business. So the idea here is I'm going to have bar keys, which will be, let's just make 5 keys for now, 5 bools. So I'm going to use true or false here. Is that what I want? Sure. I'll use true or false, and then next week I'll do something different. So true, they have it. False, they don't. Just to remind you, by the way, so what are the 0 values for bools? Keys. So before we go any further, let's just see what is the default settings for 5 bools. All false. That's perfect, because I don't want them to have any keys to start the game. Okay, so as I'm doing this, though, I'm going to show you an idea that can be very helpful in your code if you're going to use this kind of puzzle idea. You can actually create, so what I'm going to do is I'm going to create labels for the keys in my array. And the way you do that is I'm going to say, what do I want to? I'll do colors, right? So I'll do the red key will be at position 0. The blue key will be at position 1. The green key will be at position 2. Red, green, red, blue, green. The purple key will be at position 3. And the gold key, you'll have one gold one, be at position 4. Some people think that it's good practice. Let me make sure I did this right by compiling it. Okay, yeah, it's just complaining because I'm not using this, but it doesn't complain. So anyway, what I've done here is I've made a label for each of the positions in this array, which is going to make my life easier as I develop this. So if you're going to use this kind of array and key or tracking idea, it can be very handy to label all of the positions with a unique label, and then I'll show you how that works here in just a moment. Okay, so it's going to look something like this. So let's start up a menu. What do I want here? Do I want numbers? Do I want letters? I can't decide. I could do symbols if I want. What the heck? Is that kind of weird? It's kind of weird. I'm still doing it. Yeah, no, I'm not. That's a terrible idea. It is not a good idea. So I'll just use numbers. So let me fire up a bunch of these things. I'm just going to do a few locations. I'll have an option to view my keys, and I'll say I'm go to, I don't know, what kind of theme do I want? Trying to think of a theme here. I'm going to go flowers. If I don't know flowers very well, I guess I'll keep... but I need some alliteration. So sorry, I'm just having a moment where I'm not being very creative. To alliterate apple and some kind of apple... Having a theme, kind of a creativity blockage going on here. Okay, so... Yeah, just not coming up with anything right now. So I guess, oh well, too bad. Do a candy thing. So Candyville, Choco Town, that kind of stuff, right? View my keys. I'm just going to do a couple. My labels seem kind of silly with the colors, but it's too bad. Okay. Bar choice int F. Just going to prompt them like that, and then I will scan in their choice. Being careful to get that ampersand in there. So this is nothing new, which is why I'm not talking about it. Sorry about the moment where I was going to move this so that my menu kind of all goes together. There we go. I think that's nicer. So we will switch. Let's use a switch just for fun. So case 1. Candyville, and I will make a function, and I'm going to be passing in my keys, and I'm going to be passing in slices. Now, why am I doing this? Because I want to actually be able to give them keys and take away keys in these locations. So while I have a fixed set of 5 possible keys, if I want to be able to give them a key in Candyville, I have to use a slice expression to make that possible, which is one of the things we learned this week. And we'll practice it more next week as well. If I go to Choco Town, same thing. I want to be able to give or take keys away from them. I want one more. I have time to do one more. I don't know. So what's coming to mind? Case 4, view keys. Technically, I don't have to pass a slice to the view key thing, but I'm going to go ahead and do that because it might give me some flexibility later. And then a complaint. Oops, I forgot case 0. Break the loop. Goodness gracious, what a lot of mess. What a lot of mess. What a lot of mess. I'm going to go ahead and clear the screen here too. Okay, so that's just some main menu kind of stuff. You've seen that before. This break down here on case 0 will cause the whole game to pop out. I should probably say thanks for playing. Playing. Should pop out of the whole loop at that point, which should be way down here. Okay, so now I got to put these locations in, or I'm going to have an unhappy computer here in a moment. So let's put the locations in. Candyville, which I want to accept keys, which is a slice of bool. So notice here I don't use a slice expression. The function doesn't care about that. Func Choco Town, Texas Slice of Boole, Funk, Gumdrop Alley, Keys, Boole, and then finally Funk U Keys, Keys, Boole. So I'm going to start with, well, let's just put a little printf. You have arrived at Candyville. And then quickly copy that over. So this is what I recommend you do, by the way. So I've made my menu and have my sort of the locations that I want. Have my tracking of the keys in this case specifically. And then I'm just going to make the functions without doing anything in them. I'm just going to make sure that I can do a little bit of testing to see if my switch statement takes me to the right destination. So just change the messages so it's easier for me to see when I'm testing. So enjoy your stay in Choco Town, and then Valley. And then view the keys. So here we'll say coming soon. I haven't done this part yet. So this is what you ought to do. You sort of imagine your larger arrangement. You get a menu kind of spun up that lets the user pick the location, and then you have the functions that represent the locations, but you don't do all of the crazy logic in the locations before you know for sure that the program runs and that you can actually navigate with this menu. So can I go to Candyville? That's unfortunate. So I already know there's a problem because that clearing thing is happening before I want it to. So I need to pause in each of these locations. I probably want to clear the screen at each of them too. That's a pain in my rear. But I immediately notice like there's just a flow problem. So I'm going to clear the screen every time I go to a location. And then I'm going to pause as I depart. Which probably means I don't need this anymore. We'll find out. Okay, so that's the beginning. I should have had a welcome message there. Yeah, got to do it. Right here. Before that initial pause. Welcome to Land Goodies. I should capitalize that. Land Goodies. So I'm kind of just editing my display as I go right now. I'm doing okay on time. All right, that's better. Should I have cleared the screen there? Probably, darn it. Probably so. Maybe I'll do it. So this kind of thing, one of the things I mean to be pointing out to you is that this getting it to look pretty takes time. It takes some experimentation. I'm going to stop and rerun the program. So I'm not going to keep going when I see something I don't like. All right, that's fine. Cleared the screen. I'm good with that. Now, if I go to Candyville, does it clear and say I'm in Candyville and then pause? Yes. So when I press enter, does it clear and then show me the menu? Yes. So all those things are where I want them. Choco Town? Clear, yes. Gumdrop Alley, yes. My keys, nope. Well, yeah, no, that worked. I just haven't done the, and then can I quit? I can't quit. That's a bummer. I cannot quit. That break did not quit. So I better go fix that right now. So I'm just going to change the loop so that as long as quit remains false, which it will be to start, the game will keep going. And then when they press 0, I will say quit equals true. I'm going to put the thanks for playing way down here at the very, very bottom after all is said and done. All right, so I noticed that my loop wouldn't stop. So let's see if that fixes it. Okay, perfect. Okay, so the keys. Let's work on viewing the keys. So there's two ways I could do this. I'll try one way and then I will try the other. So we will say your keys. Your keys. I'm not going to put these new lines here. I'm just going to line up. So my first idea, well, no, let's try it this way first. So I'm going to how do I want to do this? I think what I'm going to do is put some words out there. So I don't need the I do need the N. True or false over the keys. So no, I do need the I because I can do this, you see. I can convert the I into the colors that I did. So if the I is red, I can, this is a kind of a pain, but still. Ooh, I got a better idea. Parallel arrays. Well, no, let's not mess with that just yet. Let's not worry about it. We'll just say, yeah, so when I says red, we will print out red and a space. Else if I equals green, green in a space, else if I equals blue. So the reason why I created the words at the top is so I could kind of write code that is easier for me to remember. So what is red? So when I is 0, that's the same as red, right? That's all I did there is make it so that if I means red, print red. If I means green, print green. If I means blue, print blue. That's what all my consts at the top allowed me to do, is not have to remember which number exactly blue is, because I made, I labeled that value. So format purple, purple space, else if I equals gold, then I can print gold. And that's it, I think. I don't have any of the keys to start. N declared but not used. Oh, yeah. Oh. And N equals true. So if I'm on the red key and it's true that I have it, then I'm printing the thing. Put that everywhere. So it's not just that I'm on the gold key, but do I actually have it? Okay, better. So if I view my keys, I should just say your keys. Oh, that looks terrible. Let's put a new line after the for loop. Yeah. In fact, 2 of them. Before the pause. Try that again. View the keys. I don't have any. That's as expected. So let's quit. Let's give ourselves a key to start. So I'm going to give myself the blue key to start. This is why I did those consts at the top. It's because I don't have to remember what position blue is. I can just use the word blue. So I'm going to give myself the blue key right from the start and just see if when I go view my keys, the blue one is in there. So I have the blue key. Isn't that nice? All right, so we have the blue key. Now how do we use it? So when we go to a location, like Candyville, we could say if keys, so if you have the blue key, you could say you use the blue key to open something, a box. Fine. And you find the red key. And then I can do this. You found the red key, so I can say keys red equals true. And now you should have the red key, in theory, after you go to Candyville. So let's try it. So view my keys. I have the blue key. That's great. So I'm going to go to Candyville. Says that I found the red key. Let's see if I actually did find the red key. Now I have the red key. I'm very, very happy about that. So that's probably enough. I can stop a few minutes short tonight. Anything else that I would do would just be kind of figuring out interesting things I can do with the keys. So this const up here, the whole reason for doing that is because I didn't want to have to remember that the red key is at position 0. It's way easy to just sort of attach a label to 0, and then I can refer to the red key instead of having to remember it's at position 0. So now I don't have to remember. I just say the red key now, please, or the blue key, or the green key, and so on. So anyway, you can use this for items. You do or don't have an item. You can use this for locations. You have or haven't been to the location. You could even do something like this. Since I do have a few minutes, I can do something like this. I can say var visits. I have 3 rooms. So I could do something like this as well. So I can say, I can add in here also the rooms. So I can say Candyville Taco Town and Drop Alley. It's 2. Now I got to adjust all the equal signs so that they look nice. This doesn't do anything other than make it look like I care what it looks like. I think I can probably put a blank line in here. Okay, so now I can do the same thing with my visits. And what I can do then is I can pass my visits. I'm just going to do Candyville as an example. So Candyville, I can pass the keys and the visits to Candyville. And then I can say in Candyville, visits, which is a slice on some integers. I can say if visits CandyV is 0, I can say F welcome first time visitor, else I can say this is your %D visit to Candyville. Visits CandyV. And then every time they come here, so before they leave, let's just say you just finished another visit of Candyville. All right, so just to show you another potential application is that you could keep counts of things that are happening as your player's moving around the world. So I'm going to count how many times they visit at least Candyville and see if that works. So let's go to Candyville. It's my first time. Makes sense. When I go back, should recognize that I've been here before. So this is my one visit to Candyville. I forgot a new line in there. That's probably not the prettiest way to do that. So before I leave this for your consumption later, new lines, you have been here sent the times, just in case, one time or times. Go to Candyville, yeah, first time visitor, been here one time, been here 2 times, been here 3 times. So there's another application of that. Ooh, you know what? I should not have them pick up the red key twice. No sense in having them get the red key if they've already got it. So I should check that they have the blue key and also that they don't yet have the red key. Okay, that's it. I will put a link to this. Next week, I will do some kind of combination. So hopefully I have time like I did tonight to stay inside of our hour and a half and give you some ideas to work on Project 3. If you haven't started working on Project 3, you need to start. If you need to worry about a theme, then start there. If you kind of have an idea for how you might like the game to play, you can use a keys-based puzzle. Like if you have this combination of keys, then you win. You could use counters to sort of keep track of points or health or those kinds of things, and a player can play until they've earned enough gold, or you know, if they should, their character should perish in the game. And then the other version has if you want to collect items, and of course you can make combinations of these things and have a bigger game. So you need to start thinking about this project. You need some kind of a theme. It doesn't have to be the super best theme ever in the world, but you don't want to be sitting there staring at the screen saying, what theme do I use? So find a theme. Hopefully one of these ideas so far puts you in a direction that you think you can manage for doing the project. And then next week, I'll do something a little bit bigger, I hope, where next week we'll be able to actually consume items, meaning we can drop items and leave them in places. So that should be fun to do. Okay, anyway, that's it for me. Have a great week. Canvas inbox, Piazza discussion and for questions, and office hours. So if you need help on anything, all those channels, as we always have, please make use of them if you need the help. Otherwise, I hope you have a nice week. There will be links to my, not the lab code that I did, that's video only, but there will be a link to my examples that I started with, and then versions 1 and 2, so you can get some ideas for Project 3. Links to all 3 of those things. Okay, have a great week. I'll see you on Tuesday next week.